Hello and welcome to Autology, the podcast that brings you the latest on automotive technology. Today's podcast is called Chassis Matters on a Roll with ZF, and you are here with me, Matthew Beecham, and Patricio Barbale, Principal Research Analyst in the Automotive Supply Chain and Technology Group here at S&P Global Mobility, and Andre Angelk, Head of System House Vehicle Motion Control at ZF Group. Hello to you both, and thank you very much for joining Autology.
Thank you, Matthew, for inviting us here to that podcast, and I'm very pleased to answer your questions here, hopefully in the right way.
You're most welcome.
Thank you, Matthew, for the kind introduction.
You're very welcome, Patricio. You know, it's quite incredible how much has changed in the world of chassis technology over the past decade. We've really seen some amazing advancements in materials, design, and engineering that have transformed how vehicles perform and keep us safe on the road. Today, we're going to dive into some of these very exciting changes. We'll discuss the unique challenges ZF faces when designing chassis for electric vehicles, things like balancing weight, efficiency, and performance. Plus, we'll explore how integrating chassis with advanced driver assistance systems is making our vehicles safer and more functional. And of course, we can't forget to look ahead at some of the future trends in chassis technologies that might just reshape vehicle architecture as we know it. So, Patricio, the first question I have for you is, how have chassis technologies evolved over the past decade, please?
Thank you, Matthew, for this question, because it's very interesting. We have seen a lot of change in the chassis domain in the last 10 years, mostly towards electrification of the component. If I can give you some example, the power steering system changed from 35 penetration of EPS in 2010 to 90% penetration today in the market, eliminating the fluid from the hydraulic system to the EPS, increasing the performance of the system. And the same situation we have seen and we are seeing in the brake actuation system, moving from hydraulic system to electro hydraulic. In 2016, we have a very small penetration of electro-hydraulic system, near to 1%. Instead, today we have like 50% penetration worldwide of electro-hydraulic system, moving to overcome the penetration of hydraulic system in 2026. And this is done mostly for the alternative propulsion vehicles. So electric vehicles and electrification of components are driving this change towards electric components. And the same we are experiencing into the damper domain. So just to cover all the components we have in the chassis domain. Of course, in this case, the penetration of active damper or semi-active dampers is lower compared with electromechanical, electro-hydraulic brakes or EPS. We are talking about 10-15% penetration worldwide, so it's something that is more dedicated to high-level vehicles. But we think that in the future, with new evolution of vehicles towards autonomous driving, we will see higher penetration of semi-active and active dampers also. And I want to say that we are in the middle of a transformation because we are waiting for the next step that will be by-wire components, and we will see in the next year the evolution of steer-by-wire, the evolution of brake-by-wire, all these technologies that will be developed with the idea of moving towards autonomous driving. So in conclusion, we are in the middle of a transformation. We have seen in the last 10 years how we move from hydraulic system to electro-hydraulic or electric EPS, and we will see in the future the change toward by-wire components.
That's great. Thanks very much, Patricio. You know, it's very interesting to see how the future of mobility is not just about new tech. It's actually about creating a seamless driving experience that prioritizes both efficiency and safety. Andre, may I come to you? Could you? I wonder, what challenges does ZF face when designing chassis for electric vehicles?
Yeah, well, there's more than just a challenge we are facing towards the change to the electric vehicle. I think we are all aware of that the whole industry is in full swing of the biggest transformation of the whole industry ever. Electrification is one, And secondly is also the focus towards the software-defined vehicle, and finally also autonomous driving, which is still a bit ahead of us, but anyhow, also these three megatrends are what we have to be prepared for. And we anticipate these overarching changes and transformation in our so-called Chassis 2.0 strategy. And what is it all about? First of all, what are the radical changes we have to implement in our overall strategy for chassis and chassis technologies? There are some overarching topics like the industry speed is rapidly increased. Yeah, we have the so-called China speed. We have definitely enhanced safety requirements, new competition and cooperation, shifting markets, and definitely also changed revenue pools. And last but not least, digitalization in products and processes. And what does it mean now, especially for our products and our overall strategy we've built in within ZF? First of all, the biggest topic for us is to have flexible and scalable electrical architectures and software from our systems. We are classically or historically a hardware-driven system supplier. Therefore, the overall actuators still play a major role within ZF. But coming back to the point, flexible and scalable software architecture will mean that we have to orchestrate our control strategy and control logic over the whole electrical architecture within the vehicles the OEMs are launching. So from more centralized domain architectures towards pure zone architectures with function deployment is where we have to be prepared for. From a hardware perspective, for us, this means we have full by-wire technology in all three dimensions. So longitudinal, lateral, and vertical controlled systems, steer-by-wire, brake-by-wire, and also for vertical with semi-active and full active dampings as by-wire. And software gradually separated from hardware. Therefore, also, we have built in our so-called Cubix software. Cubix is a vehicle motion control software. It's a pure software as a product which we offer to the OEMs as an answer to the overarching change. All in all, we still have classical components like chassis components, but also there we bring technology and intelligence into it. We call them our smart components for digital solutions. And beside Cubix, our full software, definitely functions and features we can use for update capabilities and also offer as a standalone opportunity for the OEM to be integrated into the vehicle. But finally, answering directly to the question of major changes towards battery electric vehicles. We have a significant increase of air spring systems due to the fact that the weight of the cars from battery electric vehicles is much, much higher. And therefore also a lot more focus on comfort. Comfort means semi-active, full active damping system like our S-Motion. We went into serious production already. And due to the longer wheel bases, also the rear wheel steering. We were the first in 2015 with a pure steer-by-wire with the rear wheel steering, which has a significant growth rate towards battery electric vehicles due to longer wheelbases, and we have to do to reduce the turning circle, can reduce significantly the turning circle with that.
That's great, Andre. Lots going on there. Thank you very much. Thank you very much, both, for that really interesting intro to chassis. Patricia, can I turn back to you, if I may? How is chassis integration with advanced driver assistance systems being approached these days?
Yes, as I mentioned previously at the end of my previous question, the next step for chassis will be the change towards autonomous driving and ADAS. So the new technologies that we will see in the chassis domain will be prepared mostly for this transition to the next step of autonomous driving. We will see, for example, steer-by-wire that, of course, is link with autonomous driving, even if we don't have a big penetration of high level of autonomous driving yet, but still we have a lot of functionalities that are increasing autonomous features in the vehicle. And for this reason, the steer-by-wire system will allow these new functionalities, like for example the foldable steering that will be an option in the high level of autonomous driving. The same for brake-by-wire. This is another system that is coming to the market, starting with still electro-hydraulic system, but the next step will be the electromechanical braking. So we are also here changing toward a better control of the system, of the braking system, to allow autonomous driving. And also, as Andre said already, we are seeing changes in the damper and suspension to improve the comfort of the vehicle. And this is also driving towards the autonomous driving, because with the autonomous vehicle, the passenger of the vehicle will experience more motion sickness. And one way to prevent this is to use more advanced systems to control the height of the vehicle. But the most important thing, it will be the integration of the control of all these components together. So we are seeing OEMs and suppliers moving towards an integrated control of the EE architecture, the increase of domain controllers, zonal controllers that will allow to the different braking, steering, damper system to collaborate. And I mean, a notable example of this integration can be the case of Tesla, that started years ago with the introduction of advanced EE architecture on the vehicle, and now will be one of the first vehicles with, I mean, the Cybertruck is one of the first vehicles with steer-by-wire. And we expect Tesla to introduce electromechanical brakes in the next generation of vehicle. So this is a good example of how electrification and autonomous driving are integrated together. So in conclusion, we believe that will be big changes still to happen in the chassis domain in the next 10, 15 years that will go in the direction of autonomous driving.
Thanks very much, Patricio. You know, it's very interesting to learn about some of these profound changes in chassis technologies, particularly as we move towards high levels of autonomous driving. The advancements in steer-by-wire and brake-by-wire systems that you mentioned there are not just technical upgrades. They represent a kind of a paradigm shift as we, really how we interact with our vehicles. Andre, can I turn back to you, if I may? What future trends do you foresee in chassis technologies that we could reshape vehicle architecture?
Yes, I've mentioned already our Chassis 2.0 strategy for chassis hardware, software, and chassis architectures. And clearly, the big game changer will be the adaptation towards by-wire technology in all three dimensions, with the first introduction of steer-by-wire, brake-by-wire, like EMB, electromechanical brake, and definitely also damping with fully active damping systems. Altogether, with our vehicle motion control software Cubics, the OEM can now adapt our systems and the systems nearly plug and play to his needs. But all in all, there is more. Finally, let me sport a bit about the future chassis technology, taking the full potential of electric drives into account. E-drives could be easily seen also as a negative acceleration actuator, by at the same time completely reshaping the whole brake control logic. But now I have to stop on that to not entering the strictly confidential information area of CF, and therefore stay tuned on that.
That's great. Thanks very much, Andre. I do have just one final question for you both, if I may, concerning electromechanical brakes. When do you anticipate widespread adoption of this technology, and what are the main drivers behind its development? Andre, can I start with you?
So we at the F expect the first introduction of brake-by-wire electromechanical brake systems by 2026-2027. It's a little bit differentiation between the markets, Asia Pacific, Europe, and North America, but I cannot give you more details on that. However, the pace of the introduction and the penetration in the market remains very, very dynamic. More widespread adoption will likely happen beyond 2030. Along with the increasing electrification and the introduction of modern electrical architectures. The real main driver is the improved packaging of brake systems, the complexity reduction due to much fewer components, which simplifies vehicle assembly, free up space in the interior and engine compartment. It's also enabling individual wheel control through the smart actuators, and furthermore, it provides more software configurability and functionality for highly automated driving, which definitely pays into the transformation towards a software-defined vehicle and automated driving. Additionally, the drag reduction is another benefit which reduces CO2, brake dust, and improves range extension. All in all, with a combination of the eDrive, I've spoiled already a little bit for, this will be the future.
Thanks very much, Andre. That's great. Patricia, what's your take on this?
Yes, I cannot agree more with Andre. I mean, with our analysis, we expect the same timing in terms of introduction of this technology. We expect for the end of 2026, beginning of 2027. And we expect a few vehicles at the beginning, but then, of course, after 2030, 2031, we expect a higher growth of this technology. So by 2036, in our first analysis, we expect to have a good penetration of electromechanical brakes that can be around 15-20% of the market. And I also agree on the main drivers for this technology. And one of these drivers that is the integration and freedom in the design that you can allow with this new technology will be fundamental for the rapid growth of this technology. So if we think of the new platform that are coming after 2028, 2029, OEMs are going to integrate more vehicles, different vehicles into same platforms. This will open an opportunity for technologies that are easy to integrate on different type of vehicles.
Great. Thank you very much, Patricia and Andre. Very interesting indeed. Well, unfortunately, that's all we have time for today. So a big thank you to you both for joining Autology.
Yeah, thanks, Matthew,
Thank
also
you
for having us here and giving us the opportunity to answer your great questions.
And thank you to all you listeners for tuning in as well. We'd love to hear your thoughts on today's episode at our autology@spglobal.com email. And you can find out much more at autotechinsight.ihsmarket.com. And don't forget to hit all the subscribe, follow, and like buttons to stay on track for the latest Autology podcasts. And we very much look forward to you joining us again next episode. Bye for now.